Okay, good morning class. So today we're looking at the grade 9. Grade 9. Psych, there was a control test, control test 1 of 2023 of school. Okay. So this paper was for 2 hours, 90 marks. So let's read it. So we are given the list. Okay. We're given the list of given the list: natural, integer, rational, irrational, real, non-real for each of the numbers listed below. Write down which number type of the list applies. Note more than one type may apply. Okay. The example, negative 8 is an integer, rational and real. So pi over 2. Pi over 2 is, pi itself is irrational. Not so. So pi over 2 will be irrational and real. The cube root of negative 64 is negative 4. So this is an integer. It's a rational because it can be written as a fraction, and it's real. Not so. Now the square root of negative 12, the square root of, or the even root of any negative number is non-real. Not so. So this will simply be non-real. See any confusion here? Huh? No? Look at number 1.2. Write these numbers in scientific notation. So what's the scientific notation? We have one significant figure in front of the comma other than 0. As we know, the comma is currently lying there. So we're going to move with 3, 6, 9, 12, 13, 14. So in other words, this can be written as 3,468 times 10 to the 14. Remember, when the comma moves to the right, to write it from ordinary, sorry, left, to write it from ordinary to scientific notation, it is positive. Okay? Thank you. Alright, so in 1.2.2, so currently the comma is lying here, as you can see. So this comma might move to one significant figure other than 0. So it's 1, 2, 3, 4, 5, 6, 8, 9. So that would be 1,207 times 10 to the negative 9. Okay. Then we are asked in 1.3 to express 0,67 recurring as a fraction. So where do we start? We say let x equals 0,67. 67, 67 and so on. So how many numbers are recurring? 2. So I multiply this line by 100. So it's going to be 100. X is equal to 67, 67, 67, 67 and so on. So what we do is we change the signs on the line. So we subtract, change that to subtraction. So x minus 100x is going to give you negative 99x is equal to, then of course that cancels, and that's the reason why we did what we did. So 0 minus 67 is negative 67. Divide both sides by negative 99. So x is equal to 67 over 99. Is there any number that goes into 67 and into 99 without remainder? No? So that is your answer. Alright. The next one. Allows you to calculate. We've got 1, 3 multiplied by 10 to the negative 1 multiplied by 4.2 multiplied by 10 to the negative 3. Leave your answer in scientific notation. So firstly, we're going to multiply 1.3 by 4.2. Now 13 times 42 will be 2 times 3 is 6. 2 is 0 first. So 4 times 3 is 12, carry 1. 4 plus 1 is 5. So it's 546. 546. As you can see, there's 2 digits. There's 1 digit off the comma and here's another one. So I must move this 2 units. So it's multiplied by 10. When I'm multiplying and bases are the same, you add the exponent. So negative 1 plus negative 3 is negative 4. You all agree with that? Okay, is that correct? Let me know if I'm making a mistake. You all agree with that?
Yes, sir.
Alright. Let's go with number 2. Given a polynomial, okay, so there should be other questions following soon. So given the polynomial 15x squared minus 12x cubed, 12x to the exponent 5 plus 8xy squared plus 1 minus 4x cubed y. Arrange the polynomial in descending powers of x. So descending means what? Biggest to smallest of x. So I'm not worried about the y. So that is the biggest, so it's negative 12x to the exponent 5. And then there's the x squared, x cubed, so it's negative 4x cubed y. Plus, so remember there's no sign, so it's plus 15x squared plus 8xy squared plus 1. As you can see, x5, x3, x2, x1 and no x. So it's in descending powers of. Then in 2.2 they want to know the numerical coefficient of x. The numerical coefficient is the number. Not so. The number is of course 8. Okay. What's the numerical coefficient of x to the 5? Negative 12. Then in 2.3 we are told subtract 2x to the 5 minus 3x squared plus 9 minus 11xy squared from the given polynomial. So whatever follows from we write first. So the given polynomial must be written first. So it's going to be negative 12x to the exponent 5 minus 4x to the exponent 3y plus 15x squared plus 8xy squared plus 1. Or I could have written the given polynomial is the same. Sorry? You wrote that first.
No, sir. Between the given polynomial and the one you don't right now, let's change the answer. If you take the top one, or the same answer.
You should get the same answer. If you're going to use that, you should get the same answer as this because those two are the same. Okay? Subtract, so this must be minus, in brackets, 2x to the exponent 5 minus 3x squared plus 9 minus 11xy squared. You all agree with that? So what do I do now? Get rid of this bracket here. Multiply this negative in. Okay, so let's do it together. Negative 12x5 minus 4x cubed y plus 15x squared y and x squared, sorry, plus 8xy squared plus 1. Carry on. Minus 2x5 plus 3x squared minus 9 plus 11xy. So what am I going to do now? Looking for like terms now. Okay, so it's negative 12x to the exponent 5 minus 2x to the exponent 5 is going to give you negative 14x to the exponent 5. Remember, when you add and subtract, the variables stay the same. So negative 4x cubed y is a like term to nothing. Not so. So what happens? I just write that down. Negative 4x cubed y. So it goes up. Okay. Then I got 15x squared is a like term to 3x squared. What's 15x squared plus 3x squared? 8x squared. Not so? 18. Yeah, sorry about that. And then 8xy squared is a like term to 11xy squared. Not so? And what is 8xy squared plus 11xy squared? 19. xy squared. Sorry? On the 18th. Yes, sorry man. Sorry about that. And what is, and of course this one is a like term to that one then. So what is 1 minus 9? Negative. Okay. So any confusion there? Okay. Number 4 says, okay, so what I'm going to do is I'm going to delete this here. I can keep the original polynomial in question, in focus. So here we are told that we're going to use this one. Okay. Now we are told if x is equal to negative 1, y and y is equal to 2, determine the value of the polynomial. So wherever I see x, I put a negative 1. So it's negative 12 times negative 1 to the 5. Minus 4 times negative 1 to the 3 times y, which is 2. Plus 15 times negative 1 squared. Plus 8 times negative 1. Y is 2. And must be squared plus 1. Alright. So you got negative 12. Let's sort out the exponents first. So negative to an odd exponent will always be negative. And 1 to the 5 is 1. Minus 4 into. Negative to the exponent odd will be negative. 1 cube is 1. Times 2 plus 15 into. Negative to an even exponent. Positive. 1 squared is 1. Plus 8 times negative 1. And 2 squared of course is 4 plus 1. So before I can do anything else, what do? Simplify the terms. Not so. So what's negative 12 times negative 1? Positive 12. Negative 4 times negative 1. 4 times 2. 8. 15 times 1. 15. 8 times negative 1. Negative 8 times 4. Negative 32. Plus 1. What's 12 plus 8? 20 plus 15? 35. 35 minus 32? 3 plus 1? We got an answer of 4. Okay, just let me know if I'm going wrong. No? Any confusion thus far? No? Look at question 3. Simplify the following, leave your answer with positive exponents. Because anything to the power 0 is 1. So it's 4 multiplied by 1 plus 1. 4 multiplied by 1 is 4 plus 1 is 1. Or you could have just pulled a line there and said 4 plus 1, which is 1. Okay. Let's do the next one. When we're dividing and bases are the same, what do you do to the exponent? Subtract. So 3 going to 3 once, 3 going to 9 plus. It's 1 over 3. Where's the more x's? On top. So it's going to be x 2. So 5 minus 3 is 2. Where's the more y's? Bottom. So 4 minus 1 is 3. Okay. Or you could have written it without that one, which is x squared over 3y. Okay. You guys understand? Right. So 3.1.3. The question says you got 2m to the negative 2 multiplied by 3m to the negative 3 multiplied by m. So we sort out the coefficients first. 2 multiplied by 3 is 6. And if there's nothing, there is a 1. So the answer is going to be 6. M to the negative 2 times m to the negative 3. When we're multiplying in places are the same way, add the exponents. So m to the negative 2 plus negative 3 is negative 5. And there's a 1 here. Plus 1 is going to give you negative 4. But what's the instruction? Positive exponent. Is this a positive exponent? No. So this is naturally over 1, not so. And only that goes down. Leave the 6 on top, because that negative is only on the x. So it will be 6 over x to the exponent. M to the exponent. Okay, I've written the x there as well. So m. Okay. Sorry about that. Any confusion there? The next one. 3.1.4 for 3 marks. You got in brackets 4ab over 12a squared b4 all to the negative 2. So what do we do first? We're going to simplify inside the bracket. Not so. So make the sum a bit simpler. So 4 goes into 4 once, so make the sum bigger. So 4 goes into 4 once, 4 goes into 12, 3 times. So it's a third. Where is there more a's on top or at the bottom? Bottom. So it's a, 2 minus 1 is 1. Where is there more b's? Bottom. So 4 minus 1 is 3. And this is raised to the negative 2. So because of this negative, what's going to happen to this fraction? It'll flip. So if I take that into account, it's going to be 3ab cubed over 1. It must be squared. Did I have to put this over 1 here? No, you could have left that out. What is 3 squared? 9. A, 1 multiplied by 2 is 2. B, 3 multiplied by 2 is? Okay. Given in 3.1.5, could I take the square root of each piece? Can I say the square root of 9 is p squared, so it will be 3p plus 4p? Can I do that? No. Why not? Because there is a plus. Whenever there is a plus or minus between it, we can't take the individual roots there. Okay, we must make it one term. Okay. So what do we do? Let's first add this like terms. So what's the square root of 25? P squared. As 9p squared plus 16p squared is 25p squared. What's the square root of 25? 5. Square root of p squared? Okay. Next question says expand and simplify. Expand and simplify. So what do? I use the distributive law. Not so. So what is 7d multiplied by 3d squared? 21d cubed. What's 7d multiplied by 8? 56d. Can I add those? Why? I like those. 3.2.2. We got w minus 1 multiplied by w plus 9. So again, distributive law. 1 time our w times w, w squared. W times 9, 9w. Negative 1 times w, negative w. And negative 1 times 9, negative 9. So what do I do now? Like terms. It will be w squared, 9w minus 1w, 8w minus 9. Okay. The next one, we must first apply the square. Okay. This is one of 2 ways of doing it. I'll do both ways. Okay. So you're going to do the binomial square rule. So the negative 4 remains on the outside. So I square the first term, what do I get? Y squared. So the first term times second term times 2. So y multiplied by 5 is 5y. 5y multiplied by 2 is 10y. And then 5 squared is 25. So what do I do now? Distributive law. Okay. You multiply the negative 4 in. So it's going to give you negative 4y squared. Negative 4 times 10y. Negative 40y. Negative 4 times 25 is negative 100. The question and the question paper and memo can be found in the description box below. Okay. Okay, this is the alternative method. I could have written this out twice first. So it's y plus 5 times y plus 1. Now I can do one of two things. I can either multiply the negative 4 with the first bracket only, or I multiply the brackets out. And that's what I'm going to do. I'm going to multiply the brackets out first. So it's negative 4 into y multiplied by y, y squared. Y multiplied by 5, 5y. 5 multiplied by y, 5y. 5 multiplied by 5, 25. Then we multiply the negative 4 here. Or you could have add like terms here. Okay. So it's going to be negative 4y squared minus 10y minus 10y, not it, 20y. 20y minus 20y minus 100. And of course that gives us negative 40y minus 100. You see how much shorter it is if you apply the rule. Okay, but you need to know the rule. You're getting the rule now and then, right? Rather than multiply it out all the time. Okay? Write it out twice and multiply it. Next one. What needs to be done first here? The most inner bracket. Okay. So we're going to get rid of this by multiplying out the curved bracket. Okay. So let's go and multiply that in. That will be negative, squiggly bracket, negative x plus 3, log x squared. Now 2x multiplied by x is positive 2x squared. 2x multiplied by negative 10, negative 20x, log minus 6, squiggly plus x squared. Yes? Y plus 2, I'm shorting that in. Thank you. Third mistake now for the spectrum. You? I wouldn't have gotten a chocolate. No, we lost a couple of marks already. Alright, so what do we do now? Sorry? Multiply the square bracket. Alright. Or we could have added. Like okay. Let's multiply in. What do we get? Negative squiggly bracket, negative x plus 3x squared plus 6x squared minus 60x plus 6 minus 6 squiggly plus. What do I do now? Multiply the negative, get rid of the squiggly bracket, not so. Multiply this negative in. But okay, that cancels, not so. Right, so what do I get? X, positive x, not squared. Positive x, positive times negative is negative 3x squared. Negative times positive is negative 6x squared. Negative times negative is positive 60x, and that 6 is gone, plus, now what? Like this. So x plus 60x, 61x. Not so. Negative 3x squared minus 6x squared. Negative 9x squared plus x squared. Negative 8x. Or negative 8x squared plus 61. Will you guys understand? See any confusion? Alright. Question 4. Okay, so the question says factorize fully. So now what we're going to do is we always look for a common factor first. Okay, and as you can see, what is common here? 11. A to the exponent 5, b cubed, and c. Remember the common factor must occur in both terms, and we take the lowest. Okay. So we ask ourselves, okay, 11 multiplied by what is 121? 11. a5b cubed c multiplied by what is going to give you a5b cubed c? Nothing. So it's just by 1. Not so? And 1 times 11 of course is 11 plus. 11 multiplied by what is 11? 1. A to the 5b cubed c must be multiplied by what? To give you a7 b cubed c squared. A squared b cubed is already there and c. Okay. Easy, no? Yeah. Okay, we'll do another one. Alright, so I know you guys didn't do it yet, but for the benefit of the paper and the recording, we're just doing everything. Okay. So 9xy into x minus b minus, in brackets, b minus a. So is a minus b the same as b minus a? No. So what I need to do is I need to swap it around to get it the same. So it's going to be 9xy into a minus b. If I swap this around, a negative comes out, making that negative a positive a minus b. How many terms are there? 2 terms. And what is common in the 2 terms? A minus b. So if I take a minus b out, what am I left with? 9xy plus 1. Because I took the whole term out. That's your answer then. 4.3. So this is the difference of 2 squares here. So what's the square root of x squared? The difference of 2 squares. As you can see, both are perfect squares. What's the square root of x squared? X and x. 1 plus the other minus. What's the square root of 64? 8. Okay. And it's also known as the conjugate pair. That is what is going to go into. 4.4. What's the square root of a minus b squared? A minus b. What's the square root of 1? 1. So again, that is the difference of 2 squares. As you can see, it's a minus between. So as you said, the square root of a minus b squared is a minus b. A minus b, 1 plus 1 minus. And then square root of 1 is 1 and 1. Can you see again? The conjugate pair there. Can you see, people? So clearly the conjugate pair results in the difference of 2 squares. Okay, so this is a trinomial. As you can see here, we draw a product line. The factors of a squared is 1 and 1. So the coefficient of a, the factors of 18, 1 and 18, 2 and 9, 3 and 6. Because that is plus, we have to add our products. So 1 times 18 is 18, 1 times 1 is 1. You add it to get 19. I'm looking at 9. 1 times 9 is 9, 1 times 2 is 2. Gives you, if you add it, you give you 11. 1 times 6 is 6, 1 times 3 is 3. You add it, you get 9. And that's what I want. So in the bracket goes a 1 and a 3 and a 1 and a 6. As you can see, there's an a squared, so there goes an a and an a. The signs must be the same signs. Why? Because that is plus. And both will be the sign of the middle term, which is plus. Look at the next one. .6. So as you can see, what is common here? 2. So we have to first take out the common factor. Common factor overrides all type of factorization. So you take 2, and as you can see for the variables, y is also common. So what am I left with now? Y squared minus 8y minus 20. As you can see, again we have a trinomial. Okay? So on the line goes the coefficient of y squared, which is 1 and 1. The coefficient of the constant is 1 and 20. 2 times what is 20? 10. And 4 and 5. You add and subtract the products. Of course that is minus, you're going to subtract it. 1 times 20 is 20. 1 times 1 is 1. Subtract it, you get 19. We're looking for 8. 1 times 10 is 10. 1 times 2 is 2. Subtract, you get 8. Okay. So of course in the bracket goes a 1 and a 2, a 1 and a 10. So 2 1, a 1 and a 2, a 1 and a 10. Of course there's a y, so there go a y squared, sorry, so there goes y and y. What about our signs? It's going to be different. So 1 plus 1 minus, the bigger product will be the sign of the middle term, which is negative. Okay. The next one. Okay, as you can see here, again, we got the common factor of negative 6. Okay, so if I take out the negative 6 as a common factor, we left with 4d squared plus minus e squared. Why? Because if you multiply this out, negative 6 times 4d squared is negative 24d squared. Negative 6 times negative e squared is going to be positive 6e squared. Any question now? Okay. So what do you notice here? It's again difference of 2 squares. So it's negative 6 into 2d plus e and 2d minus e. Okay. Right. We're back at it. You guys have done geometry, no? Answer the following questions in your answer book. Complete the following. 5.1.1. Something or angles on a straight line are supplementary. What do we say there? Adjacent. Adjacent. Cointerior angles lie between parallel lines and are supplementary. Angles equal sides are equal. Angles opposite. Angles opposite. Equal sides are equal. Okay. The exterior angle of a triangle is equal to the sum of the two interior angles. The interior opposite. Alright, so that is sorted. Let's go to the next one. In the diagram below, we are told that AB is parallel to CD. So if lines are parallel, we know corresponding angles are equal. Not so. We know that alternate angles are equal. Not so. And cointerior angles are supplementary. The question says, determine the value of the reason of x, k and y. So what can we calculate first? We can calculate actually any one first. So let's go with k. So k is equal to 86. Why? It's corresponding angles with AB being parallel to C. So that is 86. How can you calculate x? Vertically opposite angles are equal, not so. So 2x plus 40 equals 86 degrees. Vertically opposite angles. You solve for x, you take it over, so 2x is equal to 46. Divided by 2 is 23 degrees. And of course, how you calculate y? Angles on a straight line. So y plus 86 is equal to 180 straight line. So y works out to be 90. Any confusion there? No? 5.3. So here we are told that in the diagram, AB is parallel to CD, which is parallel to EF. A2 is 16. C2, 45. A1, 1. ABC, X. CEF, Z. Calculate with reason, X, Y, Z. Where do we start? X. Y? Alternate angles. Not so. So X equal to 45 degrees. Alternate angles with AB being parallel to C. You couldn't use EF, no? Yeah, that's a different set of lines being used. Okay. So this is of course 45 degrees. Y. Y is going to be straight line. Y plus 60 equals 180. Straight line. So Y works out to be 120 degrees. Z. Going interior. But there's nothing here. However, with the 60. Can you see that, people? So you're going to say Z plus 60 equals 180. Co-interior angles with AB being parallel to EF. So Z works out to be 120 degrees. Or we could have gone with corresponding. So here's 120 already. You see that F3? Alright, any confusion, people? Both would get you the full mark, okay? Number 5.4. We are told that AB is parallel to ED, and then we are told that CD is 95 degrees, and there's 30 degrees on D. Determine with the reason the size of CED. CED. So what do we know? Exterior angle is equal to the sum of the two interior opposite angles. Not so. So what do we say? 95 degrees is equal to 30 degrees plus angle E. Why? Exterior angle of triangle. And that is triangle CED. Do I have to name this here? No. So angle E is going to be 95 minus 30, which is 65. Okay. Let's go to the second part here. Okay. CAB, calculate CAB. CAB. Are you going to calculate CAB, people? So we need it. You see that? So you're going to say, in other words, angle A. So angle A plus 65 is equal to 180. Why? So interior angles with AB being parallel to ED. So angle A works out to be 115. 150, is that correct? Right? Right, so we're now in the next diagram. So here we are told in 5.5, in the diagram below, BAC is 63 degrees, and then ACB is 54 degrees, and you have an X here. Determine with the reason the size of X. Okay, this is simple. Why? Exterior angle of triangle. Not so. So X is equal to 63 plus 54. You got exterior angle of triangle. And it's triangle ABC. So X works out to be 117 degrees. 5.6. We are told that in the diagram below, PQ is parallel to ST. Then we are told the angle P is 30 degrees or ST is 50 degrees. Calculate, giving reasons, the size of PRS. You are told construct a line through P parallel to PQ. So if I construct this line here, so I don't have, because I'm doing construction here, normally you will have to state what you're doing. Because the hint is given, I'm following the hint, so I don't have to state. Okay. So the question was to calculate this angle here. So let's call this for now x and y. Okay. Why, just to make life a bit easier for me. Or I can call it R1, R2. Will be more appropriate. Okay. Right. So, people, what would R1 be? 30 degrees. Why would R1 be 30 degrees? It's alternate angles. For those of you who can't see it, here we go. Alternate angles. Okay, so R1 is equal to 30 degrees. It's alternate angles with PQ being parallel to now PQR is TU or U. Because there wasn't a label here, I could have just said alternate angles and left it out. Okay? So it's going to be 30 degrees. And then, of course, R1, how are you going to calculate R1? Also alternate 50 degrees. Not so. So R2, did I say R1 now? R2 is going to be 50 degrees. And the reason again is alternate angles. With RU being parallel to is. So therefore angle R will be 30 plus 50. Not so. Do I need a reason here? No. They're using an Euclidean geometry rules. Okay. So that's going to give you an answer. 80 degrees. Okay, you guys understand? It's fairly simple, no? Next question, 5.7. Been a long paper, no? In the diagram below shows parallelogram. People, what's the properties of a parallelogram from grade 8? We know that opposite angles are equal. Two pairs of opposite angles are equal. Two pairs of opposite sides equal. Two pairs of opposite sides parallel. No, that's what we dealt with so far. In grade 8 we didn't deal really with diagonals. Okay, that is the grade 9 one. So with that information you could have calculated this one. Why? Because this is a parallelogram. Then we know that AB has to be parallel to DC. Why has that to be parallel? Because two pairs of opposite sides parallel in parallelogram. Yes. Yes, you will. Because if you go straight into the fact that you say that 4x plus 12 plus 3x plus 14 is equal to 180, where are you getting that from? We're getting it from the fact that these lines are parallel and we're using co-interior angles. Yes? Oh yeah, they also tell us that. Okay, so in this case you're not going to get it more. Okay, I didn't even read this finish it. In the diagram below, shows a parallelogram with AB being parallel to CD. ABC is 4x plus 12 and BCD is 3x plus 14. CD is produced to E. Calculate the value of x. Okay. So this here is not needed. Why? Because that's given there. If that was not given, this wouldn't have, you need to have said this for a mark. Okay. And the reason here is co-interior with AB being parallel to DC or CE or CB or CD. So that's going to give us 7x is equal to 180 minus 26. 180 minus 26 it's going to be 17 is 15 and 154, is that correct? 154 divided by 7 both sides, so x goes into is still carry 122 degrees. You all agree with that? Right, so let's see what this, the next question there will store for us. Hence determine the size of BCE, this angle here. So in other words, I must first calculate what this angle is, not so. So we know that 3x 5.7.2. We know that 3x, and what is x? 22 plus 14 plus BCE is equal to 180. Why? Straight line. Okay. So BCE is equal to 180 minus, that is 66, minus 40. So 14 plus 66 is 80, not so? So 180 minus 80 is 100. Okay, any confusion there? There's a couple of nice geometry questions. And of course the bonus question, we are told that in triangle CED, in triangle CDE, C is 5 times the size of E. So if we let, okay, so between the two E is smaller, not so. And D is 3 times the size of E. So E is the smallest angle, not so. So C is 5 times the size of E, so that's 5x. And D is 3 times the size of E. So that's going to be 3x. Can you see that, people? So it's going to be 5x plus 3x plus x is equal to 180. Okay, and the reason here, sum of triangles is triangle DEC. So that's going to give you 9x, not so? So divide by 9 both sides, so x works out to be 20 degrees. People, you guys understand? Any confusion? Right. All the best for your exam. Enjoy the rest of your day. Good morning, class.